Jen. I am a software engineer at Prezzee, a GDG Melbourne organizer, and also a Women Technical Ambassador. And tonight, I'll be talking about BFFs could be your new best friends forever. So just for the context, BFFs are backends for frontends. So I'd like to ask in the audience, how many of you are aware or have worked on BFFs? Well, there's quite a few. I'll make sure that everybody knows about it by the end of the talk. All right, so before I start, I'd like to share a story.
No audio?
No, sorry. You have to open.
Let me fix that for you.
Yes.
It's a technical event, and what's a good technical event without technical issues? Oh, you need to share with audio?
I did share.
Yeah.
Yeah. Sorry. That's okay. You can picture in your mind. That's
Yeah, we
enough.
all seen this movie. We all know what this is. Sorry about that. Yes, this is Charlie Chaplin's version of yeah.
Well, it looks very dull without the audio. Yeah.
Someone can hum the tune. I guess there is no music because of copyright.
Anyway, so as you saw in the video, there used to be very simpler times when there used to be one single web frontend served by a backend. But then, as time and technology grew, so did a lot of devices and new channels. And therefore, all being served by the same backend, making that backend more like a monolith. Now, over the years, there have been companies that have been trying to break apart this monolith into multiple microservices. But the problem is still the same, because each of these front-end channels have very different needs, and they're still being served by the same generic backend services. So there needs to be a lot of data processing that needs to happen at these front-end levels to be able to consume that data. So, solution, BFFs. Wow, it's not working. Cool. So, BFF is basically a very thin layer that lies between your front-end and your backend. Now, this thin layer is basically your custom backend for one particular user experience. I'd like to say that again. It's not a microservice. It's not a front-end. It's basically a thin layer between your front-end and your backend, which helps you to provide a custom backend for one particular front-end. And there lies no logic in there. There's no business logic in there. So there's not much processing happening in there. So for example, earlier, when your front end was calling your backend all the time, this time it's going to call this layer, and then your BFF layer would talk to backend for all the stuff. Now, I need to mention that if you have a very good microservice architecture, you might not even need a BFF. You need a BFF to prolong the life of your monolith. All right, so let's have a look at some of the benefits of a BFF. First, it's easier to maintain. Now, as I mentioned, it's a very thin layer. It can be independently managed, and you have the flexibility to maintain it, to scale it independently. Talking about maintaining it, given it's providing a custom backend for one particular front end, the front end team, which is using that BFF, can actually manage that BFF. And hence, they have more autonomy towards what's going in there and what's not. Next, resilient to API changes. Now, someday you decide that whatever your API response is there, you want to change it, but your front end is actually not ready to consume that response. With a layer in between, you can actually you can actually consume and manipulate your data so that your front end is now ready to be able to consume that changes and the same API and can go for graceful degradation. What you can also do is you can use caching. So for example, if your API is not available, you can serve data from your cache, and hence your front end is not down when your APIs are down. Next, better error handling. Now, with generic backend services, your front end can do as much of error processing as possible and may throw some generic errors, which is not an ideal user experience. And hence, with a BFF layer in between, you can read those errors better and make them more user-friendly. You can convert or provide more better, meaningful errors to your users. While I'm listing all these benefits, I need to mention a quick caveat that your mileage may vary. So my experiences at Prezzee while working and investigating on BFFs have been really positive. So the reason why I said that is that you may actually ask me that, Lavi, okay, you are actually adding a layer between a front end and a back end. So there's a chance there would be an increased latency. Now, to that, I would like to ask you that how much is your front end trying to process and how much it is trying to retrieve? There needs to be a balancing act between the two. Now, let me give you a very good example. At Prezzee, we actually sell gift cards, right? So if you want to buy a gift card, what we would do is place an order. So what happens is you create a draft order, then you may create a payment intent, you may use some third-party services such as Stripe or Porter, or etc. And then once your payment is completed, you might fulfill the order and then finally complete the order and give a successful response. So when that's happening, you're continuously going back and forth from your front end to your back end. But now, if you have a BFF layer, you would make just one call to your BFF layer, and the rest of the calls would be handled by your BFF to your backend. And then one single response would be given back, which is a lot more cleaner. Now, what you can do further is basically deploy this BFF closer to your backend, like in the same availability zone or in the same machine. And hence, your response time could be shorter. The other thing you can do is you can cache some results. Again, so Prezzee sells gift cards, right? So we have a bowl of cards. That means that's a list of cards that we sell, and it's not dynamic. I mean, it doesn't really change, right? So you can actually cache that response, and then you don't have to make any network calls if you have serve it from there. So that's how you can actually save on latency. All right. The next thing that you may ask is, there would be a lot of code duplication. Like if you're creating BFFs or different front ends, and then you're doing the same similar kind of things. But to that, I would argue that for each front end, they have a different need. So BFF might actually have more targeted code. And if you feel there's still duplication, then another thing is that doesn't it actually remove coupling from your front end and your back end? You can scale your BFF or different apps independently and gives you more flexibility. Okay, now let's look at an example problem. So at Prezzee, we had the scenario where we had just simple Prezzee classic website, which was served by a monolith. Simple, easy. But then we grew. So now your Prezzee classic became your consumer web. Then we have mobile apps. We have Prezzee Business, which is for different businesses who would like to sell gift cards or who would like to buy gift cards from us and maybe give them to their employees or staff. We have Prezzee Resellers, which is businesses who would like to sell gift cards to their customers via Prezzee. So it is more like B2B2C. Now, each of these front ends have different needs. For example, for mobile, you may have push notifications, location information, video uploads, etc. With Prezzee Business, we actually allow, there's a portal, there's a web interface to place orders, check invoices, etc. But with Prezzee resellers, we don't really have an interface. It's just all APIs. So even though at Prezzee we have been trying to break apart the monolith into multiple microservices, move to a microservice-oriented architecture, the problem the problem is still the same. Solution, we add BFFs. So this is one of the proposed solutions where your web BFF serves your consumer web, your Android BFF might serve Android apps, your iOS BFF might serve iOS app, and your business BFF might serve both Prezzee business and Prezzee resellers. And we slowly can get rid of the monolith. Now, you may ask that, okay, you have created so many BFFs. So how many BFFs is the right number? Now, it totally depends on your organization structure, product roadmap, and feature parity. So if you say that your Android team and your iOS team are totally different, they have different code bases, different release cycles, it may make sense to have two separate BFFs. But at Prezzee, we have a lot of feature parity between the two apps. So all the features that are available in your Android app are also available in your iOS app. We have same team working on it, and there's a very minute difference in the data set. So therefore, it makes more sense to actually combine those two BFFs into one single mobile BFF. Another example could be with business BFF. Now, as I mentioned, that Prezzee Business, it has a web portal, it has a UI, but Prezzee resellers, they don't really have a UI. It's all about APIs. Their modes of payment is very different. Then there is a very different product roadmap, different teams are working on it. So it makes sense to actually divide it into two different BFFs. And hence, we come to another proposed solution, version 2.0. Now, one thing to note is, obviously, too many BFFs can add more complexity. And even too many microservices can add complexity. All right. Now, let's talk about how BFFs fit into a micro frontend architecture. So I'd like to ask here, how many of you are aware of MFEs or have worked on them? Cool. Well, no worries. So micro frontend architectures have recently gained a lot of popularity because they allow you to decompose your frontend into little micro frontend apps that could be semi-independently managed and work loosely together in single one frontend app. And it helps developers easily to develop and release. So at Prezzee, if you look at Prezzee Business, we have a Prezzee Business interface, which is like a monorepo, and it has two micro frontend apps. One is Prezzee Business Portal, the other one is Prezzee Business Campaigns. Now, there are two different teams that work on each of them. Portal is all about your interface for businesses to place orders, check invoices, etc. Campaigns is to run promotions and all of that. Now, since there are two different teams, there's not much parity, they are very two different apps, that makes more sense to break it into two different BFFs. So now what's happening is that your Prezzee Business Portal is served by Business BFF and also managed by the same team. Similarly, your Prezzee Campaigns is served by Campaigns BFF and served by the Campaigns team. And we have now gone vertical. There is one slice of app managed by one single team. All right. So I've been just posting about why to choose a BFF. Obviously, when your front end has specialized needs, you need to have a BFF. It helps you with performance optimization, etc. It also gives you team autonomy, as in more control over the data and logic that is sent to the client. You can implement fine-grained security measures, such as you can hide sensitive information, reduce the risk of exposing critical information to unintended clients. But why not to choose a BFF? Now, obviously, it comes with developmental complexity. It needs its own developers, it needs its own resources, and hence there is an increased cost of infrastructure and maintenance. So if you're working on a smaller project, you may be better off with a monolith. Monoliths are not that bad. Plus, with so many BFFs and so many changes to the APIs, your APIs might actually get out of sync. So you might want to look at that. So does that mean that BFFs could be actually your enemies? Well, it depends. And if you feel like that, then you might try GraphQL, API gateways, or create another microservice. The next thing would be, does my current architecture have to be changed? No, because it's a thin layer, it comes in a plug and play way. So if your method contracts are not changing, you may have to make just minimal changes to be able to fit it like a Lego piece. Next, why should we invest hard-earned money and precious time in this? Now, as I mentioned, if you have a good microservice architecture, you might not want to go for BFFs. It might work really well for you. But if you are still migrating from monolith to microservices and you need more time, it will help you buy more time. It will help you increase the life of your current system. If you know that your database might start failing, you might not be able to serve your customers very soon because you won't be able to scale it, you might actually add a BFF and add more life to your system. So are you ready to befriend a BFF?
I'll try.
All right, any questions?
I have a few questions. So, do you use like any, framework or bootstrap for the BFF services? Because in general, you have to make sure that, like, if one service is down, the other services are not affected.
Sorry, can you feel louder?
Yeah,
I can't
so-
really hear you.
My question is, do you have any like a bootstrap, like a project for all of your BFFs, or you just do every BFF from scratch? Because they share kind of like things in common. Where I think the most important is to like if one of the services behind BFF goes down, it doesn't affect the rest, right? So for example, like if you have like the chain of calls into the legacy system microservices, if the first call is down, it doesn't mean that like all other calls should fail.
Yeah.
So like what kind of approach do you use, and do you have some sort of bootstrap project or seeding project that you use for all of your BFFs, where all of that kind of functionality been handled already, some sort of like a micro framework for BFFs? Do you have any?
I'm not sure if I understand your question correctly.
So the
Correct
thing
me
is like
if I'm
all
wrong.
BFFs, you mentioned you have many BFFs, right?
Yeah.
Do you have
You
any
can
like a
have.
seeding project for that, which solves a common problem for BFF?
Common problems for BFF?
Yes.
I'm not sure. I don't think
Because like
so.
the common problem is when like you start talking to multiple services and one service is down, it could actually affect kind of how BFF works. So like a short circuiting, all that stuff. So do you have
I
anything
don't
in
think
place?
the BFF should be affected if your microservice is down, because you're going to have it as an independent layer, right? The whole point is to decouple it.
I'll give you an example of what happened like just a few months ago. There was like a chain of calls. It goes first to BFF, then it goes to the underlying system, and that system was timing out. No, not timing out. It's kind of like the all kind of some of the calls were about maybe 1+ minute, right? And when you have like a lot of calls, it means the thread exhaustion, and the thread exhaustion actually affected all of the things that BFF was responsible for. And
Okay.
even though like 99% of application was working well, just because of 1% that was failing, it just ruined the whole BFF, and the application was down, like full application was down just because of the misbehaving service.
Yes. So there could have been two good approaches there. First is better error handling. Obviously, if you can't really do anything about it, then better error handling. The other thing could have been you could have cached some results, and you could have served it from the cache. That's it. I hope that answers your question. Any other questions? Cool. All right. Thank you so much. And a special thanks to Women Tech Makers team who have helped me with the travel support so I can be here. So thank you.